This is Professor Pelt, and this is Algebra 2, Chapter 7, Section 4. We're still adding and subtracting rational expressions. So now we're going to move on from monomials to polynomials, which is the Algebra 2 topic. Okay, let me turn on the pen here. So the same process applies, except with polynomials, you'll have to do factoring strategies first prior to getting the lowest common denominator. So if I do my factoring here, I get 7 over 3 x for the monomial one, plus x over, this is a factoring out strategy, they have a 3x in common. So if I factor that out, I'm left with an x plus 1. Okay, lowest common denominator. What do they have in common? They have a 3 and an x in common. What's left over? A 3 and an x. And an x plus 1. So the lowest common denominator is 9x squared times x plus 1. Okay, so same strategy, rewrite the problem. 7 over 9x squared plus x over, and we'll keep it in factored form, which is what you should do, 3x x plus 1. Okay, so don't take the original in this case, take the factored form. Except for the monomials, multiply those back together. Okay, so the first one, 7 over 9x squared, that is missing an x plus 1 to get the lowest common denominator. So we'll multiply by 1 fraction, equivalent to get that. And the 3x times x plus 1 has the x plus 1, but the 3x is not large enough, so I need to multiply that by another 3x. So multiplied out now, what do I get? On the top, I get 7x plus 7 when I multiply those through, over 9x squared times x plus 1. Keep denominators in LCD form until the end. And on the top, I get 3x squared over 9x squared times x plus 1. Now we have common denominators. We can actually add the two fractions. So if I add them, I get 3x squared plus 7x plus 7 on the top. And on the bottom, 9x squared x plus 1. Okay. Always check to see if, in fact, it is factorable, because you might be able to cancel some more stuff. So let's see. 3 times 7 is 21. The factors of 21 are 1 and 21. 3 and 7. That's going to be about do it. And none of those will give you 7 in the middle. So that is as far as you're going to get with simplifying. Okay. So this is only true where x cannot equal 0 or negative 1. Because again, this term you can't plug in 0. In this term you can't plug in negative 1 because denominators cannot be negative 1. Okay. Let's try problem B of the examples. Okay, so first primary difference of polynomials, you have to factor them first. So I have x plus 3 over, if that's a 1, that's going to give me 1x, and then that's going to give me 1 times negative 2, which is negative 2, so that's 1 times 2. Let's see. That's going to be a positive 2 and a negative 1 because it has to add up to 1 in the middle and multiply with negative 2 plus 2 over, that's really, if you think about it, x squared plus 0x minus 1. So if it's a quad form factoring, so that's x. So 1 times negative 1, this is going to be 1 times 1. I have to do a positive 1 and a negative 1 to get that 0 middle term. Okay? All right, so lowest common denominator. What do they have in common? They have an x minus 1 in common. Right? And what's left over? An x plus 2 and an x plus 1 is left over. Okay, so we have 3 binomial terms as the common denominator. Okay, so let's rewrite the problem here. x plus 3 over x minus 1, x plus 2, plus 2 over x plus 1, x minus 1. Okay, so the left-hand term is missing an x plus 1. So we'll multiply by a fraction of 1. Because again, you can't just multiply by x plus 1 because that would change the value of the fraction. If you multiply a numerator or denominator by a number, it's a different fraction. But if you multiply the top and the bottom, it's still an equivalent fraction. And the second term is missing the x plus 2. Okay, so we'll have to multiply that out. So that gives me x squared plus 3x plus 1x plus 3 over x plus 1, x minus 1, x plus 2. Again, keep denominators in factored form all the way to the end. And on the top, I get 2x plus 4 over, I'll keep them in the same order, actually, x plus 1, x minus 1, x plus 2. Right? Okay, so now we can add the numerators. So we get x squared. So I have a 3x, a 1x, and a 2x. So that's what, 6x? Plus 7 over the common denominator, which is x plus 1, x minus 1, and x plus 2. Okay? And always check to see if the numerator will in fact factor. So 1 times 7 is 7, which is 1 times 7 or negative 1 times negative 7. Neither one of those add to 6, so that is as far as you're going to be able to go there. So that is in fact your simplified term, or expression in this case, where x cannot equal 1, negative 1. I'm sorry, I got that backwards. I want to keep consistent with the order here. Negative 1 can't go in there. Positive 1 can't go in there. And negative 2 can't go into there because otherwise it would be 0 in the denominator. Okay, let's try C, the last of the examples. Okay, so again, factor the denominators completely first. So x plus 2 over, well, 2x minus 2 is a common factor of 2, which we can factor out. So that's x minus 1 minus negative 2x minus 1 over quad form factoring. So that's 1x, 1x, 1 times 3 is 3. The only factors that will work are 1 and 3. And they both need to be negative to multiply by positive 3 and add to negative 4. Okay, so lowest common denominator, they have in common an x minus 1, right? What's left over is a 2 and an x minus 3. Okay. All right, so we'll rewrite the problem. So we have x plus 2 over 2 times x minus 1 minus negative 2x minus 1 over x minus 1, x minus 3. So the left-hand term is missing the x minus 3. So we'll multiply by a fraction of 1. The right-hand term is just missing the 2. Because again, the goal is to get this LCD to both terms. Okay, so if we multiply through here, we get x squared plus 2x minus 3x minus 6 over, I'm going to rearrange a little bit here. So I get 2x minus 1, x minus 3. Same terms, just different order. Okay, and then here, minus negative 4x minus 2 over, again, I'm going to rearrange it a little bit, x minus 1, x minus 3. Okay, now we can actually subtract them. So I get x squared. So I really have 2x minus 3x minus 6, so that's really negative 1x plus 6, and it's minus negative 4x plus 2, so that's really plus 4x plus 2 when you distribute the negative to those two terms, because it's subtraction in this case, right? All over the common denominator of 2x minus 1, x minus 3. Okay, so I think we're good so far. However, x squared, that's going to give me, let's see, when I simplify a 3x, I think we messed up here. Was it a oh, it's a minus 6. That's why we copied that down wrong. So if that's minus 6 and plus 2, that's minus 4 all over 2, x minus 1, x minus 3. Fix the 4 there. Okay, so again, always check to see if you can factor. So 1 times 4 is negative 4, which is 1 times 4, or 2 times 2. One of them has to be negative, though. And if that's negative, that does give me a positive 3, so that actually factors. So that's 1x, negative 1, and positive 4 over 2 times x minus 1, x minus 3. So those will cancel. Leave us the final expression of x plus 4 over 2 times x minus 3, where x cannot equal, so let's think here, that's going to be the 1 and the 3, even though one of them canceled out. It's in the original problem. Okay, one's a whole and one's an asymptote. We'll talk about that later on. All right, pause the video. Try these student problems for yourself. Okay, student problems. We have a monomial and a binomial term. So we have what? 1 over 3 times x plus x over, let's see, 9 and 12, a common factor of 3. So that's 3x minus 4. Okay, so lowest common denominator. The only thing they have in common is a 3. Everything else is left over, which is x squared and 3x minus 4 is left over. Okay, so rewrite the problem. 1 over 3x squared plus x over 3 times x minus 4. So remember to keep it in factored form for denominators until the end, and except for monomials, you can multiply those back. Okay, so the left-hand term is missing the 3x minus 4. And the right-hand term is only missing the x squared. Okay. Oops, there we go. All right, so if I multiply that through, we get 3x minus 4. We multiply it by 1 over 3x squared, 3x minus 4, plus x cubed over, let's see, that's going to be 3x squared, x minus 4. Change the order up a little bit. All right, so that gives us a final answer of x cubed plus 3x minus 4 over the x squared, 3x squared, excuse me, x minus 4. Okay, top is not factorable. So where x cannot equal 0 or 4, because you can't plug in 4 here, and you can't plug in 0 there. So that is not going to work for either of those. Okay, let's go to student problem B. All right, so we have factoring quad form and factoring out factoring here. So the first one's quad form, so it's x over, let's see, 1x, 1x. So 1 times 25 is 25. The only factors of that will work are 5 and 5. If they're both negative, they'll multiply to 25 and add to negative 10. minus x minus 4 over 2x minus 10 of a common factor of 2, which can be factored out. Okay, lowest common denominator. So they have an x minus 5 in common, but only one of them. Okay, so what's left over is another x minus 5 and a 2. Make a better 5 than that. Okay, so I'm going to rewrite the problem here as x over x minus 5, and I'm going to put squared so I don't have to write x minus 5 twice as a shorthand, minus x minus 4 over 2 times x minus 5. Okay, let me write the minus a little bit better on the left-hand term there. Because again, I don't want to write, if you have multiple of the same term, you can just use exponents as a shorthand. It's a lot easier. Okay, so the left-hand term is only missing a 2. The right-hand term has the 2, but is missing a second x minus 5. Okay, so if we multiply through, we get 2x over 2 times x minus 5 squared, which is the common denominator, minus, we have x squared minus 5x minus 4x plus 20 over 2 and x minus 5 squared, which I'll write shorthand again. Okay, so if we do subtraction together, we have 2x minus, and what did we come up with here? X squared, and we had minus 4 and minus 5 for minus 9, plus 20 over the common denominator, which is 2x minus 5 squared. So that's 2x minus x squared plus 9x minus 20. Okay, so I think we're good so far. Let me just check this out. Yep, so we'll rearrange that. So I get negative x squared plus 11x minus 20 over 2 times x minus 5 squared. We'll divide on a negative 1 on top. So I'm left with x squared minus 11x plus 20 over 2 times x minus 5. Okay, so always check to see if there's any factoring on the top so you can get some cancellation if possible. It may or may not happen. So here I have 1 times 20. So if I check 20, that's 1 times 20, 2 times 10, 4 times 5, or double negative, right? 1 times 20, 2 times 10, 4 times 5. And none of those give me negative 11. So that's the best we're going to do there. So get rid of that line there. That is our simplified expression. That's a 20. That's a 20. Where x cannot equal just 5 in this case. Even though it's squared, it's just x minus 5 twice. That really doesn't matter. Okay, let's go to the last one on the student problem, C. Okay. So again, factor completely in the denominator. So we have x, that's a 1. So that's 1x, 1x. So 1 times negative 12 gives you negative 12. So the factors would be, let me think here, 3 and 4, but it has been negative 4 and positive 3. Multiply the negative 12 and add to the negative 1 term. Okay, plus 5 over, so the first one was quad form. This is factoring out. So I can factor out a 12, so that's x minus 4. I think that's good. All right, lowest common denominator. What do they have in common? X minus 4, obviously. What's left over? An x plus 3 and a 12 is left over. So that gives us our LCD. Let's rewrite the problem. So we have x over x plus 3 x minus 4 plus 5 over 12 times x minus 4. I am not making good fives today, that's for sure. Okay, the left-hand term is only missing the 12. And the right-hand term is only missing the x plus 3. Okay, so we'll distribute. So we get 12x over the common denominator, which again we're going to keep in factored form till the end, plus 5x plus 15 over the 12. I'm going to rearrange the order just so they look the same. Okay, it's a good habit to get into. Just rearranging so they look in the same order. Okay, now I can add the numerators since they have common denominators. So let's see, 12 and 5 is going to give me 17x plus 15 over the 12, x plus 3, and x minus 4. And there's nothing in common top and bottom, so they can't be simplified. So where x cannot be -3 or +4, because those would make the denominator 0. Okay, and that is the end of part 2.